Hi everyone. I just playing around with this. I accidentally shut the last video off, but all I was going to do to finish was going to check this, and then we'll do the next example. Alright, so y equals 5x squared minus 2x plus 7. If I graph that, okay, it's way up here. And I don't know, is that 1/5 and 6 4/5? Let's just second calc. It is a minimum. Left bound, that looks good. Get on the other side of it. Right bound, okay, hit enter. And this says basically 0.2, which is what 1/5 is, and 6.8. So that does check out. Alright, and back in the day before these kind of functions were available, and this is a relatively new thing in mathematics, in the scheme of all things, in the history of all things. I know it's been around for a little bit, but this was handy, knowing how to do derivatives, to find some place like that. All right. Now, this time I have a cubic function. F of x is x cubed minus 4x squared minus 3x plus 7. All right, guys. I need you to fight back sentimentality, fight back those tears. We are on our last example of the year in our notes. F prime of x equals f of x plus h minus f of x. The limit as h approaches 0. I did it again. Over h. And so I've got to take x plus h cubed minus 4 times x plus h squared minus 3 times x plus h, and then plus 7. That's the x plus h. And then I got to subtract f of x, which is x cubed minus 4x squared minus 3x plus 7, and I got to put all that over h, and don't forget we're taking a limit of that. Now I'm going to remember from square or cubing a binomial. I remember, like on Pascal's triangle, the 1 3 3 1 for the coefficients. This first part. Now if you want to do that, I'm just not going to. I'm just going to write down what the answer is, because I just remember how this works. So it's x cubed plus 3x squared h plus 3xh squared plus h cubed. Don't forget the limit as h approaches 0. Minus 4 times, and then this is the square. We've done several of those. There's something under my paper here that's throwing me off. X squared plus 2xh plus h squared minus 3x minus 3h. I'm just going to go ahead and distribute that. And then plus 7, and then distribute the minus. I got negative x cubed plus 4x squared plus 3x, and then minus 7. That's all over h. And prime of x equals the limit as h approaches 0. Let me just get rid of parentheses completely and then combine on the next step. X cubed plus 3x squared h plus 3x h squared plus h cubed minus 4x squared minus 8xh minus 4h squared. These three terms have come from distributing the negative 4 here. And then I'll just rewrite this. Minus 3x minus 3h, whoop, plus 7 minus x cubed Man alive. Plus 4x squared plus 3x minus 7. I ran out of room for my numerator there. And that's all over little old h. Okay, it is time to do some canceling. I see positive x cubed and negative x cubed canceling. I see 4x squared canceling with negative 4x squared. I see a positive 3x and negative 3x. And I have a negative 7 here and a positive 7 here. So my derivative, as we keep simplifying, there's a lot to this, huh? 3x squared h plus 3xh squared plus h cubed minus 8xh minus 4h squared minus 3h okay, and this is all over h, and let's factor out the h. This seems to be equals the limit as h approaches 0. Let's factor out the h in the numerator. I have h times 3x squared plus 3xh plus h squared minus 8x, fold that h out, minus 4h, and then minus 3. Pulled the h out of each one of these terms and put it up front here. That's over h, and that is canceling. And that is the limit as h approaches 0, the derivative still, right, of 3x squared plus 3xh plus h squared minus 8x minus 4h minus 3. Okay, it's time to do direct substitution now that we've got this h canceled out. And this part, we put 0 in for that term, 0 in for h here, 0 in for h here, and 0 in for h here. And our derivative, what's left standing, is 3x squared minus 8x minus 3. Okay, we found the derivative. Lo and behold. So what we do now is we set that equal to 0. We're looking for max and mins. We set that equal to 0, and I'm looking at 3x squared minus 8x minus 3 equals 0. That's where the tangents are, where the slopes are equal to 0, are at the peaks and at the valleys. So, of those tangent lines. Now, let's see, what multiplies to negative 9 and adds to negative 8? I'm going to factor this, solve it. Could use quadratic formula, but I'm going to factor instead. And that would be, looks like negative 9 times 1, negative 9 plus 1. So if I take 3x squared minus 9x plus 1x minus 3. Factor out 3x here. I've got x minus 3, and that's a 1 times x minus 3. Okay, so 3x plus 1 times x minus 3 is equal to 0. And I'm just solving for the x's. 3x plus 1 equals 0. That would be x is negative 1/3. Or x minus 3 is 0. That would be x equals 3. This one I just kind of skip some steps. I subtract 1 and I divide by 3. I get the negative 1/3. And Let me clear this and take the x cubed. Let's go back to the original function, find out what those y values are. And let's see. I will take negative 1/3 to the third power minus 4 times negative 1/3 to the second power minus 3 times negative 1/3 and then plus 7. All right, 7.518. That looks like I'm going to go approximately, so negative 1/3, and I'm just going to go 7.519 approximately. Okay, and then when I plug the 3 in, and that's a repeating decimal, it looks like it would be easy enough to change to a fraction, but I'm not going to do that right now. If I take all the negative 1/3 out and put in, what do I want? Just 3. So I delete, 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 delete. I get negative 11 here. So 3 and negative 11. Okay, now I just want to look at the graph and see if that's where we're looking at those extreme values. Y equals x to the third minus 4 x squared minus 3x plus 7. And when my window, let's see, the x's, I don't need to be so wide. I'm just going to go negative 5 to 5. But on the y's, that's 7, that's negative 11. Let's go negative 12 to positive 12 on the y's, just to get a window that might look pretty good here. All right, and let's just do a quick check then. Second calc, we want there's a maximum right here. Let's go left of it here, hit enter. Let's go right of it here and hit enter. And the negative 0.33333, and then it rounds a little bit, and 7.518. Okay, that looks like the max that we came up with. Right there. There's a max. And then second calc, let's go for this minimum here. And left bound, let's get on the other side of it. Right bound, enter. 3 negative 11 is the minimum of this function. All right, very good. I want you guys, in your assignment, to do page 777, nope, 778, numbers 55 through 58. Now, I did mention that this is the last video. It kind of went long because the examples were kind of long. But I just really want you to know how much I have thoroughly enjoyed being each and every one of yours teachers. and it has been a true pleasure of mine and one of the best moves I've ever made in my career. So thank you. God bless you. My best wishes for all of you. And good job hanging in there through all these circumstances. God bless you. Bye-bye.